Where am I? All right, today we're going to do another one of these together for PFG grade. Tomorrow I am going to put one out there for a PFG grade, but we will not do it together. It will be for you to do on your own. So I recommend, if you can, that you take a look at it bright and early tomorrow morning. And if you have questions, I've got an 8 o'clock Zoom meeting where the physics students are getting their electronics kits projects checked. Most of the time, it just sits empty. They come on for a minute or two, I check it, and then they go back off. So if you folks want to hop on during that 8 o'clock meeting, if you have questions, that can happen. So I recommend, if possible, that you do tomorrow's PFG as soon as possible. All right, same thing as we've been doing. Circle state and name. Circle what's wrong. Different, I mean, it's not wrong, it's just different. And then state what that is that's different. And the reason I want you to circle and state is that way people are much more likely to actually see what's going on. And seeing as how you may not be, in this case, you may not have the thing to circle. If you didn't print it out, then you still are writing it down. All right, so number 1, circle. Number 2, state. Number 3, name. So in number 1, oh, wait a minute, you're supposed to get started and then check back. So go ahead and work on it for a couple minutes, and then I'll start doing them, and you can check back and see how you did. While you're doing that, I shall go see if there's any more coffee made yet. Okay, so make sure you're checking back and making sure you have them right, fixing them if they're not right. Because tomorrow you have to remember how to do it yourself. Again, when you're finished, make sure you turn it in to the chemistry inbox on my Google Drive. I am missing several of you from yesterday yet. You might have to look through yesterday's video and see how it's done if you weren't here and don't know how to do it yourself. Uh, All right, if you have any questions, you know where the raise your hand button is. After you're done with the meeting, or if you've got a laptop and a phone, I suppose right now, you can take a picture of your work and submit it to the Google Drive. By the way, please put your name on your page at the top right corner before you take the picture. That way I don't have to open your file and then close the file to see whose it is and open the file and close the file. I can just keep one at a time going through your pictures and giving you credit for them. Also, as we're getting multiple PFGs, please label which PFG it is. This one would be number 8.2. So please put 8.2 at the top, especially if you're turning more than one in at the same time or turning it in late. So as yesterday, please do not tell, please do not tell the, please don't give the answers to other people. They can get them the same way you did. If they don't or can't get here on time, then they can look at it tomorrow afternoon in the recording. And anyway, so again, tomorrow there will be one for you to do on your own. If you want to do it during the 8 o'clock to 8:45-ish time frame tomorrow, if you want to, then if you have questions, you can hop onto the Zoom meeting that's not teaching, it's just checking things, and I can give you help if you're stuck with something. That may be this week only, because after this week, the seniors are gone. Although I suppose I could open a Zoom meeting during that 8 o'clock hour later if I knew you needed it or wanted it. All right, back to the notes. For some reason that I have no idea, this document, and apparently this document only, has quit offering to take me back to where I left off when I open it. And we're almost to the bottom, so I have to scroll way down. All right, we were ready to start with proteins. Proteins, as I pointed out to you yesterday, are very, very, very important. Of course, everything's important in you. You can't, even the simple compounds, you can't live without. But proteins are the machines, the workhorses, the things that actually physically do everything that gets done. I mean, proteins are amazing. I'm sure I ranted and raved about this in 10th grade, but I want you to get it. Proteins are made out of approximately 20 different modules or subunits. Okay, there's one subunit. The subunit is amino acids. So there's just the one subunit, but just the one subunit, but that one subunit has 20 different variations. So you don't have to learn all 20 variations. By the way, here are the 20 variations. They are not there for you to memorize. They're there for you to just get an idea of what we're talking about. You do not have to know the 20 variations. But proteins are made out of this amino acid, this subunit called amino acid. and there are approximately 20 different versions of the amino acid. And proteins are modular. You put those different combinations and different numbers of those 20-ish amino acids together, and you can get every protein, every machine in your body. It would be as if there were 20 pieces that everything in the world was built out of. So if you wanted to build a house, it was different numbers and combinations of those 20 pieces. Now, a house would be fairly complicated. You would need hundreds, thousands maybe of those 20 pieces. If you wanted to build a road, you would need, for every foot of road, you would need however many of those different 20 pieces. If you wanted to build a fighter jet, you would use the same 20 pieces. If you wanted to build a hammock, you would use the same 20 pieces. So proteins are like everything in your cell that does anything is built out of these, and they are modular using the same basic 20 pieces, hundreds of them, mind you, but the same basic 20-ish pieces. There are, for example, literally generators in the membranes in your cells that are proteins. They literally produce an electric current, not the kind of electric current that we use in house wiring. That is the flow of electrons. This electric current is the flow of protons, but they literally produce an electric current. There are literally in some cells rotating motors, protein motors that spin a shaft and spin a propeller, not a propeller like you think of on a airplane, but a propeller that's like a corkscrew shape that spirals out, and it makes that spiral spin. And by the spiral spinning, by the spiral spinning, it pulls or pushes a cell along. So proteins are amazing. They're get everything done that gets done. There are 20-ish pieces put together in different numbers and combinations, and they make all kinds of fascinating things. I think I told you in 10th grade, there is literally a protein that walks on another protein rail. Literally walks and grabs onto this rail. And there is another protein that builds the protein rail in front of the walking protein so that it can make the rail to wherever the protein needs to go. I mean, to say that this is random chance is just defies imagination. But if you've written off anything but random chance, then you're stuck believing that, and you can just say, wow, isn't that amazing that the impossible happened? All right, amino acids. Molecules composed of an amine group, we just talked about amines, a carboxylic acid, we just talked about carboxylic acid, and a side chain that is labeled as R. And again, just like in the substituted hydrocarbon pictures that we just did, R means any other combination of stuff. So you need to know this. But my quizzing ability is, when I say my quizzing ability, what I can type in on the LMS quizzes is limited. I can't do subscripts, I can't do superscripts, I can't do multiple lines. So I'm gonna have to draw this twice, once like it actually is, and once like I will have to do it on LMS. So we have an amine group, which is an NH2, HN2 is the same thing, just the other direction, and it is attached to a carbon, which is attached to another carbon and a double bonded O and an OH. And then on this carbon, we've got the R group. So there is the general formula for amino acids. And by the way, this is not for curiosity. That is actually something that you are supposed to know. If we were, if I was requiring a test at the end of this unit, if people want, several people, no, not a handful of people took the optional test last unit. If you want the optional test this unit, that's up to you. It will be from memory if you take it, and this formula will be one of the things on it. Most of you won't take it, that's fine. Now, let's look down here at this picture I was showing you a minute ago, these pictures. So you will notice that they do it a little bit different. They basically do it like this. NH2, I know it says 3, I'll get to that in a minute. And here's the C and the H that I had going down, and there's the C double bond O, OH. Now, this doesn't look like this, but it is. Here's what they've done. Instead of writing this O and this O separately, they write them together. They do that sometimes. They do it actually quite a bit. So instead of double bond OOH, they just write COOH. And then this H has a tendency to want to hop over here. That's not what I want. So instead of putting the H there, they put it over here to make this H3 and then the N. And this is plus and this is minus. Now, since I can't do superscripts or subscripts or multiple lines on LMS quizzes, I am going to, on LMS, I am going to do plus H3N dash CRH dash COO. Actually, change that a little bit. Didn't want that quite like that. So this is the right way. And this is the LMS quiz way. So yeah, make sure you get that written down. And those folks who just don't bother to come to the Zoom and take the OpenNote quiz will probably have trouble with that. Now, that's one amino acid. Amino acids are hooked together in fairly long chains. For example, the molecule hemoglobin, which I think hemoglobin is a great word. It's one of my top 10 or 15 favorite words for no good reason. It just strikes me as interesting. But hemoglobin has about 200 amino acids. Actually, it's 4 groups of 200, so it has about 800 amino acids in it. So these amino acids are hooked together in peptide bonds. Peptide bond is a bond between 2 amino acids, and it is formed as a result. Well, we'll just do the first part. First we'll show you an amino acid. So N, now look, this H2 right here can also be written H and H. That's still two H's, H2. So this time I'm going to write it H, H, C, H, R, C, double bond O, O, H. Okay, so if I take one amino acid, and I'm going to use some different colors here to try and let you follow what's going on. So if I add another amino acid, better not use green in case any of you are red-green colorblind. So there's another amino acid, C, R, H, C, double bond O, O, H. So when those combine, they make, now this will take me a second, don't get too distracted. H, N, H, C, H, R, C, double bond O, and now the blue, N, H, C, R, H, C, double bond O, O, H. Now, if you notice, what happens here is, I didn't want that, sorry, I wanted the highlighter. This H goes away, and that OH goes away, and the remainder hooks together right there. But that means that we've got some stuff left that hasn't been accounted for yet. So plus that blue H, changed blue shades, didn't I? And the red OH from here and here combine to make HOH is the same as, maybe you know this by now, maybe you can see it by now, that's the same as H2O. Now, a couple of things. First of all, this right here is the peptide bond. And you don't have to do colors, but you should put this picture in your notes, because somewhere along the way, somehow, if I figure it out, I'm going to be asking questions about this. And if you plan on taking the optional test, you are going to be able to need to list that. Now, just the part in the box is the bond. The peptide bond is just the part in the black box. It is not the whole molecule. The whole molecule is a dipeptide, 2 amino acids, because we had 2 to start with and we combined them. Now, this term dehydration synthesis is fairly important. This is a dehydration synthesis. The synthesis means it made a bigger molecule and the dehydration means, okay, dried out. Dehydration means dried out to you. but it wasn't wet and then dry. It wasn't wet on the left side of the arrow and dry on the right side of the arrow. If anything, it's wet, sorry, on the right side of the arrow. So the dehydration means gives off water as a product. Now, there will be questions about dehydration synthesis. And dehydration synthesis does give off water as a product. It's a reaction that makes a bigger molecule and gives off water as a product. A reaction that makes a bigger molecule and gives off water as a product. So make sure that you get that. It will be there. All right. I think the next thing is the structure. Oh, just a couple terms and then we'll get to this. We'll do these two terms and we'll finish for the day. So I told you that that last picture I drew was a dipeptide. It was 2 amino acids. A polypeptide is several amino acids. A polypeptide, I'm sorry, can be a protein or a piece of a protein. So a polypeptide, let me add that. A protein or piece of protein. So I told you that hemoglobin was made of 4 chunks of about 200 amino acids. So hemoglobin is a protein, and each of those 4 pieces that make it would be called a polypeptide. All right, essential amino acids which must be found in your diet because your body can't produce that amino acid. Plants can make their own amino acids from scratch. Animals can't, or at least animals can't make all of them. So if you can make it yourself, it's not an essential amino acid. If you can't make it yourself, it is an essential amino acid. All right, we'll stop here. Don't forget, PFG tomorrow on your own, 8 o'clock if you want help. And don't forget to get the quiz taken. And don't forget to turn in your PFGs. Please make sure you have your name and PFG number 8.1 yesterday, 8.2 today at the top. Have a good day, those of you who are still here.